So I'm going to share my thoughts in the next 10 minutes on towards the 6G enabled smart manufacturing. And as we all know, there are a plethora of verticals, in 5G and 6G. And I thought that this may be a good time to focus in on smart manufacturing. And the reason being that, as my eminent colleague spoke before me, there's a lot of thrust in India in smart manufacturing. Uh, and I think this has been enabled in the last 5-10 years, particularly. And I think with that, a thrust and added, vigor, this may be a good time to talk about the intersection between 6G and smart manufacturing. So very quickly, if you look at the 6G landscape, and I'm sure all of you are, a lot about 6G, but just a very quick few seconds summary. We do know that 6G offers, extraordinary speed, connectivity, intelligence, and highly matured networking models, right? So we've really come a long way from 4G, 5G, and now the 6G landscape. In fact, many of us are grappling in various bodies in the country and even outside as to what are the key features, characteristics that we can leverage in the vertical that we work on. And if you look at the slide, if you look at the bottom half of this slide, you will see that there is no vertical now from transportation to manufacturing to healthcare to education, as my colleague spoke about earlier, disaster management, defense and security, and the list goes on, which are not, going to be affected by 6G. So I think we've really, we've really come at a time now where 6G is going to influence significantly every vertical, and I don't think it's going to spare any industry whatsoever. If you look at the 6G use cases, it's kind of interesting. As I said, there's no vertical now that is not going to be touched by 6G. But what's interesting over here is that there are so many features of 6G that enable a large number of use cases. So whether it's mixed reality, which really is immersive shared experiences, or the digitalization for everyone and everywhere, which we call as global internet. And then you have, of course, autonomous mobility, which is critical because that supports smart transport, including autonomous vehicles and hyperloop transportation. You have critical services, which is really priority emergency communication. And then, of course, you have spatial data, right? Data is across the globe, whether it's cloud or data centers or the edge now. And I think I must emphasize that edge is becoming a very critical component of 6G now because data is closer to the IoT devices. And so you can do much more in real time than you were to, if you look back in time in 5G context. And then, of course, now you have massive digital twins, or we're envisaging massive digital twins thanks to the advances, as I mentioned earlier. And last but not the least, I think there's a revolution going on around us in AI communication enabled by super awareness and AI offload. And we're seeing an exponential growth around us, whether it's ultra fast personalized AI assistant, and of course the agentic AI. In fact, every time I talk to experts in AI, ML, deep learning, almost every organization now and institute, university is looking at agentic AI and the benefits that one can reap from agentic AI. So it's kind of an interesting time to see the intersection of 6G with the verticals that we work on. As you go ahead, if I zoom in smart manufacturing, right, which is an area that we worked on intensely in the last few years, almost about half a decade, you'll see that the intersection between Industry X.0, which really is 4.0 leading to 5.0 and 6G is remarkable, right? So if you look at this slide, you will see that the whole Industry 4.0 that was fairly, well known. The paradigm was about a plethora of technologies working together to enable smart manufacturing. But I think we've come a long way now. We now have arrived at an era of Industry 5.0, which not only includes all that Industry 4 had, but add the human centricity over there, add sustainability and add resilience there. And so that's the new paradigm of Industry 5.0, which is really becoming very critical because if you go back in time, the human centricity was really missing. And one has realized now that that is critical if you really were to have a high productivity. So if you look at the benefits of Industry X.0, that's nothing but 4 moving to 5. And of course, in future, you'll have probably the enhanced versions of 5, you'll find that there are a large number of benefits of Industry 5 X.0. I'm not going to read this, but I think they span all the way from efficiency to quality control to flexibility, But I think most importantly to the human centricity, the workforce empowerment, and the sustainability aspect of it. And I think, and the list goes on and on and on. So this is not really an exhaustive list, but these are representative benefits of Industry X.0. Now, if you look at 6G and back to the intersection of 6G with Industry X.0, we'll see that whether it's speed and efficiency, or whether it's human centricity, or whether it's sustainability, and of course, the power of AI, ML, and deep learning, as you see on the right side, all of them together really create a very, very smart end-to-end ecosystem of smart manufacturing. And that is exactly what, so if you go back in time, so here's a very quick lesson in the next 60 seconds or 120 seconds. If you look at some lessons learned in smart manufacturing, as we call smart assembly line, and this was going back a few years ago, our own personal experience, where we saw that here was this factory, which had an end-to-end, it's an end-to-end PCB assembly line. And the managers were really worried, right? They were saying, look, we don't have, so this is really a PCB, so right from the raw material, you have PCB boards coming out and finished goods or semi-finished goods. And the key challenges that the managers were facing was end-to-end visibility. They didn't even have the end-to-end visibility. For example, if a component fails or if something happens in a phase in the end-to-end assembly line, there was really no clarity and the root cause was not apparent, right? So whether it was end-to-end visibility or efficiency or productivity, including worker productivity, and performance. And by performance, I really mean, all the latencies and metrics that we need to define well. For example, end-to-end latency, the throughput, the energy consumed, or maybe the losses, and the list goes on and on and on. So it was clear that, if you just have raw industry 4.0 technologies tied up together, they will themselves not be able to really make it quote unquote a smart manufacturing ecosystem. And so it turned out that 6G, come in 6G beyond the 5G revolution, we see that now there are factories with a large number of robots. We're now seeing the advent of 6G powered real-time material digital twins. We're seeing autonomous swarm robotics for hyper-efficient production. There's a near zero latency industrial IoT for seamless supply chain synchronization. And then, of course, if you look at 6G from the point of view of haptic telepresence for remote industrial operation. And finally, 6G integrated human digital twin for worker safety and productivity. We now are seeing, the entire circle being covered, right? So what's fascinating here, what's exciting here is how the features or so-called characteristics of 6G are really impacting smart manufacturing, and they're making it smarter and smarter. And that's something we would love to, I suspect that that's going to only grow with time. And my last few slides over here. So I think one of the most important features of 6G is the influence of AI, machine learning, deep learning, and now, of course, generative AI. And I suspect, and this is, of course, what we've been discussing with a lot of folks, including industries and universities in smart manufacturing, that you'll find, and you're already finding prototypes with AI-driven near zero latency smart factories, smart assembly lines, right? And the objective is, as you see below, right? These are self-learning, self-optimizing production lines. These are, I won't say defect-free, but they're by and large defect-free, fully automated systems. Of course, they're AI-powered, flexible, and sustainable in terms of manufacturing. But I think there's a the picture is very rosy, and I think it must, it should be, it is, because the influence of AI, ML, and deep learning. But if you look at the challenges that I've listed in my last bullet in the concluding remarks, I think that's something that will keep us busy and also a little bit worried. So in conclusion, and before I come to the challenges, and of course, these are challenges, that we have to resolve as researchers and practitioners. But let's kind of look at, if you look at the 6G landscape, it's clear that it's going to be leveraged by almost all the industry verticals in course of time, number one. Number two, I think the time has come to define some killer 6G use cases that I think everyone across the world, across all the continents, is grappling with what are these killer use cases. And in this context, particularly as they feed into the Industry X.0 paradigm, I think there's a dire need to define use cases in a more constrained environment. I've been talking to a lot of colleagues across the globe, and I think one of the things that is very clear is that an environment, for example, the rural environment or the semi-urban environment, where the connectivity is limited, where the resources are limited, if we can enable 6G intersection smart manufacturing industry X.0 there, I think that is going to be extremely beneficial for reasons that you all some of you have mentioned earlier. And finally, I think we have great challenges in the intersection of 6G and Industry X.0 or smart manufacturing. In my view, and my 2 cents, are that the biggest challenges lie in security and privacy, and not just security and privacy, which is the end-to-end context of supply, smart manufacturing, but also the trustworthy AI. How do we know, and I think my colleagues earlier mentioned that, how do we know that these AI ML models are trustworthy? I mean, number one. Number two, they're secure. They ensure privacy. They ensure, zero bias. They ensure transparency. And I think these are very hard problems, but a lot of research across the globe in Europe, in the United States, in India, and in the Asia Pacific, they're trying to address or grapple with these issues. So I think the future is certainly rosy. It looks very exciting, but if we don't address the trustworthy AI and the end-to-end security and privacy issues, it's going to be quite, we're going to be grappling with very serious challenges going forward. And my final slide, I think the areas are so important that we started, these 2 top-notch conferences in this part of the world in Bangalore. One is the AI ML Systems, which happens every year in October, and the other one is CommsNet, which happens in Jan every year in Bangalore. And the nice thing is that CommsNet is covering the whole 5G, 6G aspect. AI ML covers the entire machine learning, ecosystem. So it's interesting to see, and I think my colleagues earlier mentioned, the whole power of global collaboration. I think I couldn't emphasize more on that, because without collaborating with like-minded folks across the globe, as is also the objective of this forum, I don't think we'll be able to make much progress if we limit to only our own ecosystem.